Good morning. My name is Sander and I took my cluster over. There it is. And the purpose of this talk is that we are going to configure it. It's just rebooting because of some weird problems with video output. Don't know what it's doing, but I do know that when I reboot it normally works properly. I like being root on this demo machine. It's the only user that exists anyway. Looks great. So I have 10 slides here. I don't want to do much slide talking. I want to do demo most of the time. The title of this session is Creating a Cluster in 20 Minutes. This is a session where I normally request 3 hours to cover everything. The guys who organized this minicon were kind enough to give me 20 minutes to talk through the configuration of a cluster. I hope you do realize that in a 20-minute time frame I can't cover all the details, but I should be able to give you a rough outline. If you're interested in more, the book Practical Guide to Xen High Availability, I wrote it as a book about Xen high availability. I'm not trying to sell it here. Of course you are welcome to. Just send me an email and I'll be happy to send you the PDF. It's a book that I tend to give away for free, and normally people like it. So some of them are selling it, are buying it. If you wonder what's a weird accent, that's because I'm from the Netherlands. I left the day before yesterday. In my time zone it's about 3 a.m. now, I believe. So if I fall asleep, please help me, wake me up. You are more than welcome to ask questions to make it easier for me to stay awake. And if you don't understand my English, I'm always glad to repeat it in Dutch, in French, or in German. Anyone who speaks Dutch here?
Goedemorgen.
Goedemorgen, heel goed. Wees welkom. You are not from the Netherlands, are you?
No, better.
Okay. Okay, great. Let's not talk encrypted. So basically this covers the entire setup of the cluster. 3 bullet points. So the first thing we need to do to set up the cluster, we need to set up a cluster communications layer. The communications layer is a CoroSync layer. It's basically a configuration file that makes sure that nodes in the cluster can find each other. By default that works on multicast. So the nodes are all configured to use a specific multicast address, and all of the nodes that are multicasting on the same address, they tend to find each other and add each other to the cluster automatically. I'll show you how that works. Then we need to start up the cluster service, and then we need to configure resources. If you want to configure resources, normally I like using the CRM interface, which is a command shell interface. There's also the CRM GUI, which is a graphical interface. It gives more information, so in this session I will show you how to do it with the CRM GUI. So enough slides for the moment. Let's go to demo. This is SUSE Linux Enterprise Server. One of the nice things it has is the YAST configuration utility, which helps setting up the CoroSync configuration in an easy way. It's easier to see what exactly it is doing while you are using YAST. So instead of talking through the configuration file, I talk through the configuration as it's offered by YAST. Of course, the inconvenience is that it's slow. VI on the configuration files much faster. So basically this is everything you need to do in order to set up the cluster membership layer. What you can see here is first that there's a communications channel. The channel is the bind network address. This typically is the network address where the cluster has to send its packets over to get in touch with the other nodes. Typically you would design a nice networking solution using redundant links and bond interfaces to make sure that the cluster will never lose its network connection. Because if it can't reach the other nodes anymore, well, that means that the other node is no longer available, and that means that the cluster has to do something. Then you need to configure a multicast address. I picked a random multicast address from the 239 range. The 239 range is used for private multicasting, and you can be sure that within that range you don't have any hardware that uses it by default. And we need a multicast port as well. Now in the cluster, all of the nodes have a node ID. The node ID should be unique. If you choose the option to automatically generate the node ID, you automatically get a unique node ID. Now, in case you are using multiple links for the cluster communication, that's the top item that we have here, the bind network address. You can specify which protocol to use. Of course, in my situation, it's the non-protocol because I don't have redundancy. You can set it to active, you can set it to passive. Some more configuration. Security, you can configure a secure authentication file. This is very useful to make sure that you don't have additional nodes in the cluster by surprise. In the previous version of this software, the software wasn't this advanced, and what happened is that, well, I took my laptop to a customer site, and hey, we were using the same broadcast over the same network, and suddenly my node appeared in his cluster, and it was kind of hard to get it out of there. So if you want to make sure that you don't have problems like that, make sure to enable secure authentication. That basically creates a key file that you can copy over, which functions as a shared secret to make sure that, well, no nodes automatically appear by surprise. Now the service itself, this speaks for itself, and that's enough. We can finish here. Now the result is in a configuration file, the etc corosync. The name of the configuration file is corosync.conf, and of course you can use VI to create the configuration here. If you've seen the configuration from Jas, it's not that hard. Is that a question?
Please move your terminal window over.
Yeah, thank you very much. I wasn't aware of that. That's better. I'm missing a little bit on the left. So once you have configured the corosync layer on all of the nodes in the cluster, they will automatically find each other, provided that you have started the service as well. On SUSE Linux Enterprise Server, the name of the service is OpenAIS. So let's do a service OpenAIS status, and it gives us that currently the service is running. Now, I never believe it when it's telling me that it's running. So another way of seeing that it's really doing something is by using the CRM_mon tool. CRM is an essential part of the cluster. It stands for Cluster Resource Manager. It's a part of the cluster that decides on which nodes in the cluster resources are going to be running. And CRM_mon is the monitoring tool. There are other CRM tools available on your computer as well. Just do CRM tab for auto-completion. Because it has too many options, it doesn't auto-complete, but it just shows all of the options that you have available. You will appreciate these commands while working with the pacemaker cluster from the command line. Now, in here I want to do CRM_mon. And CRM-mon shows me that I have a cluster which is up and running. Current DC, the DC, it's not the domain controller, it's the designated coordinator. It's, the master node in the cluster, the node that synchronizes the CIB.xml. CIB.xml is the core configuration of the cluster that needs to be synchronized between all of the nodes in the cluster. Now what we can see here is that we have a partition without quorum. What is quorum? Quorum is the minimal amount of nodes that you would expect to be present in the cluster. And typically clusters will consist of 2 nodes instead of 1. I didn't want to take too much laptops over to Australia, so I have a 1-node cluster here. It's complaining about it. 1 node configured, 2 expected votes, and we don't have any resources configured yet. Okay, and that's going to be the next part of my presentation, the configuration of resources. Now, in order to do that, I'm going to use CRM GUI. And CRM GUI, by default, wants to use a user account HA cluster. There's a group configured, created on your computer when installing this software. It's HA group. Any user that is a member of the HA group can configure the cluster using CRM GUI. I'm just using the default user, which is HA cluster. So let's start the CRM GUI. Nothing shows. In order to have it show something, I need to log in to the cluster. So that's my username. Server, that's just the local IP address, the loopback address, which is good enough for this purpose. I need to log in. It will take a couple of seconds for it to update the information from the server. Basically, what it's doing while it's updating the information from the server, we have the CIB, CIB.xml is the core component of the cluster. And it is reading in the CIB configuration that exists on the designated coordinator. You can see here my current CIB configuration, which is pretty empty. But in this CIB configuration, you can see a part that has a CRM config with all of the generic parameters for the cluster. You can see the nodes part to define all of the nodes that exist in the cluster. You can see the resources. Well, we don't have any resources yet. So let's move on and create some resources in this nice cluster. So this is a graphical overview. And all you want to see in the graphical overview is green balls. Because if you see nothing but green balls, that means that the cluster is completely operational. Now there's 2 parts in it, configuration part and the management part. Of course, in order to create a configuration, I need to go to configuration resources. As you can see, there are many generic properties that you can set. I will talk about some of those properties later in this session when I'll discuss the 5 things to avoid when setting up a pacemaker high availability cluster. For now, I want to create a resource, a very important resource, the IP address. It's just a dummy resource, but for demonstration purposes, it's the easiest resource to configure in the cluster. So I'm going to configure a clustered IP address here. And you will see what exactly the procedure is that you have to go through while setting up something like that. Now when I click add, it asks me what exactly do you want. I have 4 different things, 4 different options here. I can create a primitive, a group, a clone, or a master. Now, in most situations, you would create a primitive, which basically is an independent service that you want to run in the cluster. A group is, well, a group of primitives. If, for example, you want to set up Apache for high availability, you could typically create primitives like an IP address, a file system resource, and the Apache web server, and put them all together in the group. And because of the fact that they would be in the group, that means that the cluster will try to load them together and also in a specific order, which is nice. But for the purpose of this demonstration, I'm not going to do that. Then we have the clone. The clone is a primitive that has to be activated multiple times simultaneously. So typically the clone could be something like a database that you want to have running on 3 different nodes in the cluster at the same time. Or a cluster-aware file system, for example. OCFS2 is an example of such a cluster-aware file system. You want it typically to be available on multiple nodes simultaneously. So for those cases, you would choose the clone. The master is a typical example of the clone in which one of the clone resources acts as a master, where the others are slaves. I'm clicking OK, and I need to provide an ID, my IP. Sounds like a nice name. And then I need to specify which class of primitive I want to use. Now, there are 4 of them. Most of the times you would be using OCF. OCF stands for Open Cluster Framework. It's an open standard that defines how resources need to be managed in the cluster. But in order to use OCF, you need an OCF resource agent. The resource agent is like a script that looks a lot like the init script that you find in your run levels, typically. You could say that an OCF script is an init script on steroids. So if it's available, you would always use an OCF. If it's not available, you can use LSB. LSB, which stands for Linux Standard Base, which is just a typical init script that you can use in the cluster as well. Then option number 3 is Heartbeat. Heartbeat is clustering old style. It's a resource type that you should always try to avoid. It really is old, it's lame, you don't want to use it anymore. And it only exists for the purpose of backward compatibility. Maybe useful if someone has developed his own resource as a Heartbeat resource. And then we have STONIF. That's the nicest acronym that you can find in IT. It stands for Shoot the Other Node in the Head. The idea of STONIF is that if in a cluster node 1 thinks that node 2 is no longer available, node 2 should really be terminated. So node 1 uses some hardware mechanism to shoot node 2 in the head. And it goes down, and while it is down, you can be sure that, well, the resources can be taken over securely. And that's important because, well, if you don't, you might see some critical issues. I've seen it once that the other node wasn't shooted in the head properly, and the result was that my ext3 file system got mounted twice in the cluster, and that 2 nodes together were writing to my ext3 file system. It took us about 8 seconds to find out that it happened. It took us about 4 hours to repair the ext3 file system. STONIF is essential. So in this example, I'm going for the OCF. Then we have the provider. The provider basically is where the OCF script comes from. It doesn't make sense to me, the different categories, so I'm always guessing, and I think Heartbeat is the provider for the IP address. So we see the list of available OCF scripts here. The one I need is the IPadder 2 address. Initial state of the resource is stopped, which means that the cluster will create a resource, but it won't automatically start the resource. I want to set that to started, so that it comes up automatically. And then we have the option add monitor operation. Resource monitoring means that the cluster is actively going to check if the resource is still available. And that's essential because it means that if your resource goes away and you have a resource monitoring, the cluster can tell, hey, the resource has gone away, let's start it again. And that is one of the most important parts of a high availability solution. So now I do forward and it asks me for the instance attributes. The instance attributes is basically the properties of the resource itself. For an IP address, it shows me all of the mandatory instance attributes, which is an IP address. So I do edit and I give it a value like 192.168.1.101, whatever. I do OK. And if you're wondering, do we have any other instance attributes? Just click Add again, do the drop-down list, and you will see the other instance attributes that are provided by the resource agent. Just pick the instance attributes that you think you might need. As you can see, only the IP address is required here. So, since it requires only the IP address, I'm not going to do anything else. I'm going to apply, which creates the resource in the cluster. Let's see from the management perspective. Oh dear, my resource isn't running. Oops, did I fill my demo? No. I made critical error number 1 while setting up this cluster. So let's move over to the next part, which will be basically in my presentation, which is about critical errors that you should try to avoid at all times. We have had that. Common problems and errors. So most of the items that I'm going to talk about now are about some generic cluster properties. And when things go wrong while setting up the cluster, it's often related to one of these. Now I can tell you I've set up somewhere between 10 and 15 different clusters, I think. I have made all of those critical errors myself, and I can assure you that the cluster is not going to work if you try to make them as well. Now, the first of them is a no quorum policy. That's a property that you can configure for the cluster, a generic property that you can set from the graphical user interface that we have just seen. And this property decides what the cluster is going to do if it doesn't have quorum. That means that if you have a 4-node cluster and you lose half of the nodes, quorum typically is majority in the cluster, so if you lose 2 nodes in a 4-node cluster, you will lose quorum. The default setting for no quorum policy is stop, which means that everything stopped, which isn't very convenient. So there are some other options as well that you can choose from. What I like a lot is ignore. I don't care if I lose quorum. Because while setting up the cluster, I take care that one single node in my 4-node cluster can handle all of the resources in the cluster. So if I just have one remaining node in the cluster, I want my resources to run all of them on the one single node. I don't care about quorum. I don't like quorum. Other options, you can freeze the current situation, so nothing will be stopped resource-wise, but nothing will be moved in the cluster either. Or you can do a suicide, which is useful in some specific cases. Even more important, no stonif. I really hate this option because they have changed it in Heartbeat somewhere between version 2.0.7 and 2.0.8. The old setting was for stonif. The old setting for stonif enabled was that even if you don't have stonif, well, the cluster will run your resources anyway. The new and current setting is if you don't have stonif, the cluster doesn't start any resources. My example of the IP address, we have seen that I configured my IP address correctly. The only reason why it's not running is because I didn't configure stonif. Now, what exactly is your STONIF solution? Your STONIF solution typically is a hardware device that is capable of shutting down the other node. Like a rack PDU, for example. In a rack PDU, you can talk to the rack PDU by telnet and tell the rack PDU, hey, shut off port number 4. Or like a DRAC or an ILO interface board in your server. Or another solution which I like a lot is an SBD, which stands for Split Brain Detector, which is a dedicated partition that you create on your SAN. All the nodes talk to the dedicated SBD partition, and if one of the nodes seems to be down, the cluster writes a poison pill for that node to the SBD partition. And if the node in question sees the poison pill, well, it will eat it and it will stop. It will go into a kernel panic. Nice mechanism. Also particularly nice because it's easy and cheap to set up. You don't need any specific hardware if you want to try the cluster for yourself. Common error number 3 is resource monitoring. You always want resource monitoring on your resources, because without resources, the cluster will, without monitoring, I mean, the cluster will always be happy about the resource. And it will always show your resource as available, which might not be the case because you didn't use any resource monitoring. Starting resources is another common error. Now, if you configure the cluster wants to take care of starting and stopping resources in your environment. Now, why is that a problem? Well, on many Linux distributions, if you install, for example, Apache, Apache will be added to your run levels automatically. So normally the distribution assumes that if you install a service, that Linux needs to start the service. That shouldn't be the case. In order to work with resources in a cluster, you need to remove the resources from your run levels so that the cluster can start your resources. Because otherwise the cluster is going to try to start a resource which has already been started. And the cluster doesn't understand that too well. And last but not least, resource stickiness. What's that? Resource stickiness means how bad does the resource want to stay on the node where it actually is. The default value is that the cluster is trying to place the resources in an optimal way. Which means that if something changes to the current state of the cluster, well, your resource may move away from one node to the other node. Your users are not going to like that, because while moving away the resources, the resource will be shut down and it will be started again on the other node. And that can be a pain for your user. So make sure that you give your resource stickiness a positive value. Any value higher than 0 will do. Typically it's a number. I like putting the number 10,000 for resource stickiness, but that's just more or less random. Pick anything between 0 and 1 million. I think I'm out of time. That's it. Thank you very much.